everybody, here we're going to go over the instructions for the error lab. So first thing, don't forget to enter your student ID in cell A2. And now I'm going to do several of these with you, and then you'll do the rest. So let's see how you're going to do these steps here. So first thing is that for each of these instruments, you're going to record the error here, and make sure you only record the number with no symbols or only just the numbers. And here you're going to select the corresponding SI units. So let's go ahead and do the meter stick. So depending on the meter stick, you have to you're gonna get the values are gonna look slightly different. So here, this manufacturer shows you that there's 1, 2, 3, 4, and this little here, what that corresponds to is those smallest tick marks. So for the meter stick, the smallest division is in millimeters. So let's see what these smallest tick marks correspond to. So this is going to be 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these tick marks correspond to 1 millimeter, and this one here that actually corresponds to 1 centimeter. So for this meter stick, the value for one division, so x1 div, is equal to 1 millimeter. And the next thing is we have to decide whether these tick marks are wide or narrow. But just from looking at it, these tick marks are actually pretty close together, so the meter stick is going to have narrow divisions. So then the error for the meter stick is going to be 0.5 multiplied by 1 millimeter, or it's going to be 0.5 millimeters. So we're ready to enter our answer. But the one thing is that, remember, we need to convert, well, let's go ahead and do that now. The units that you're going to enter for the meter stick, they have to be in SI units. So that means that even though there's an option for millimeters, centimeters, and meters, pick the SI, which is going to be in meters. So because of that, you're going to have to convert from millimeters to meters. And that's pretty simple here. This is just going to be 0.5 millis times 10 to the minus 3 meters. So what we're going to enter into Excel is just this value, the 0.5 times 10 to the minus 3. So here, this is actually something particular to Excel, is that whenever you want to write a power of 10 in Excel, there's a special way you're going to do that. So first we're going to write 0.5, and instead of writing 10 raised to the minus 3 in Excel, just type E. So E means 10 raised to, and then after that we're going to put the minus 3, and that's it. That is going to be so that's all we need to put, and then we can enter the answer. So don't worry that Excel changes the format. As long as you entered it properly, that's going to be the correct value. So this should be 0.5, 10 to the minus 3. And remember, don't enter any symbols, plus or minuses, or any percents, because all that is going to, the program won't be able to read your value. So we've done one of them. We've done the meter stick. So now let's go ahead and let's do the stopwatch. So when you click on the stopwatch, this is the link that's going to appear. So let's try to get the error for the stopwatch. So let's just start it and let it run for a little bit, and then let's pause it. So there, looking at the stopwatch, it's a digital display, and if you look at it while it's paused, there is no fluctuation. So let's see how we're going to record that. So the number that we have is 2.25, but there is no flux, no fluctuation. So this is the last digit that we know exactly. So there is an error, but what this means then is that we just have to put the error 1 decimal place behind that number. So we're going to put the error here. So the error for the stopwatch is going to be point. Drop this down. This is a 0. Drop this down. This is a 0. And here you're just going to put a 1. So that is going to be the error for the stopwatch. So the delta t for the stopwatch is going to be 0.001, and also seconds. So let's go ahead and enter that. So this is going to be point, zoom in, this is going to be 0.001. So whenever you have a digital display and there's no fluctuation, the error is always going to be a 1. So it's always going to be a 1 placed at 1 decimal place behind the last non-fluctuating digit. And so here the units are going to be seconds. So I'll let you calculate the error for the protractor. One thing though is that even though in most cases the units are supposed to be in SI units, but for the protractor you're going to select the units, select degrees. Even though they should be in radians, you're going to select degrees. And I'll also do the thermometer with you. So for the thermometer, even though again the units are supposed to be in this case kelvins, but this is physics 1 and you have beginning of physics 1 and you haven't encountered that yet, so just go ahead and leave the units here in degrees Celsius. Okay, let me also do the spring scale with you, because that one is going to be a little technical. So if you click on the spring scale, this is the link that's going to appear. So let's see how you're going to read the spring scale. So first thing is to increase the screen to as big as you can, and here we're going to have to, so here the units are pretty odd, so we still need to find the smallest division, and in order to do that we're going to use the formula that I showed you on the first page. So first thing is, let's get you can pick any number. Let me just say that X total, the biggest number that I want, is going to be, let's just say that is 0.5. And the next thing that we have to do is to calculate the total number of tick marks to that value. So if you zoom in starting from the 0, there's 1. It's hard to see, but 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, there's 10 divisions between from 0 to that value. So then the value for one division is going to be 0.5 divided by 10. So that will be 0.05. So that's going to be the value for the smallest division. And now we want to get the error for it. So this is mass, so kilograms, that's mass. So the error in the mass, again, these are going to be, if you zoom out, they're going to be narrow divisions. So because of that, we're going to multiply this by another 0.5. So this is going to be 0.5 multiplied by the value for the smallest division, which is a 0.05. So then the error for the meter stick is going to be 0.025. And now you can enter, so that is going to be the error for the spring scale mass, and it's going to be in kilograms. So then here for the spring scale, the error is going to be 0.025, and the units are going to be kilograms. The only thing though is that the error needs to be rounded to 1 sig fig. So then we'll change this to around the sub to 0.03. So now you can do the rest of these. For this digital thermometer here, again, treat it like a stopwatch. So that 0 there, that is going to be a non-fluctuating digit, and based on that, find the error for this digital stopwatch where this last 0 is not fluctuating. So that's going to be let me repeat myself. So this digital thermometer, the 0 here is a non-fluctuating digit, so you're going to use the same steps that I showed you for the stopwatch.